Hey guys, welcome back. We are starting a new chapter. We're starting chapter 10 in our Big Ideas math book. So if you want to kind of follow along and look in your book or reference your book, a lot of this information is in there. So there's some cool figures and example problems and things like that to check out. Now today we're going to cover kind of two sections in one, which kind of sounds like a lot, but it's actually going to be pretty easy, I think. We're going to have a kind of a nice mellow day after our test. So we are actually doing 10.1 and 10.2 today. Okay, and chapter 10 is all about parallel lines and relationships that happen with parallel lines. So what you're going to see a lot of today is you're going to see a lot of shapes that look like this. Parallel lines, or sometimes not parallel lines, that have a line that's going through them. Okay, we'll kind of explain what those different pieces are, but you're going to see these figures quite a bit. You're also going to see 4 new angle relationships today, and one of those angle relationships is called corresponding angles. So let's think about the relationships that we have already, angle relationships. We have complementary angles that sum to 90. We have supplementary angles that sum to 180. We have linear pairs where they're adjacent and supplementary. We have vertical angles that are congruent to each other. We have all the different kinds of angle relationships, and we're going to get 4 more today. And the first one we're going to talk about is called corresponding angles. Okay, so let's talk about that. So what we got here is we got 2 lines. They're not parallel, but they kind of go in the same direction. And then we have another line cutting through them. Okay, this line right here, this line that cuts through the other 2, is called a transversal. Okay, cuts it in half. So corresponding angles represents the angles that are on the same corners, basically, right? So think of this like you're driving down the road, right? You're driving down this road, this transversal road, Transversal Boulevard. And you have these 2 intersections, right? Here's an intersection, and then here's an intersection, okay? Corresponding angles is kind of like if there's a building on the same side of the street, right? So if you look at number 1 and number 2, if we're talking about a map, and this is north, east, south, and west. This is kind of like these are both on the northwest corner, right? So if you're driving down the road and you come to an intersection and there's like a gas station here, and there's like a Taco Bell here, and there's like a Walmart here, and there's like, I don't know, Costa Vida here or something like that, right? These 2 guys are on the same corner. This is like, the northeast corner, or the northwest corner, excuse me. So those are called corresponding angles because they're on the same corner of the intersection, right? They're both on the upper left, in other words. Okay, 3 and 4 are also another pair of corresponding angles. These guys would be like the southwest corner, okay, where your Costa Vida is or whatever. Now, of course, they're probably not the same restaurant, but you get the idea, right? And here you got the northeast corner, so 5 and 6 are corresponding angles. And then you got 7 and 8 are corresponding angles. So I color-coded them for you. And again, the way I remember corresponding angles is like on the same corner. So you got 2 intersections, right? These are both on the southeast corner. These are both on the northeast corner, southwest corner, northwest corner. So those are corresponding angles. And those are the pairs there, okay? Now, there's a theorem called the corresponding angles theorem, and we're not going to prove this one today, but we will tomorrow. We're going to talk more about the proofs for these theorems. Today we're just going to talk about the theorems and how they work and the names of the angles and things. We'll go through proving them tomorrow. But the corresponding angles theorem says, if 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So notice here, these aren't parallel. I made them to be not parallel, and that's okay. You don't have to have parallel lines to have corresponding angles. You can have corresponding angles even if the lines aren't parallel or the streets are crooked. Okay. Now in this one, these are parallel lines. So the difference here is these are parallel, and I've marked them parallel with this symbol right here. If you remember that, it means parallel. Okay. So if these 2 lines are parallel and they're cut by a transversal, so here's our parallel lines, and here's our transversal. Then we get something extra. Then what we get is the corresponding angles are congruent, right? So again, corresponding angles aren't always congruent, but they are congruent if the lines are parallel when the transversal is cutting it. So if that's the case, then 1 would have to be congruent to 2, and 3 would have to be congruent to 4, and 5 would have to be congruent to 6, and 7 would have to be congruent to 8. So the lines have to be parallel for that to be true. So corresponding angles theorem. Lines got to be parallel. If that's true, then your corresponding angles are congruent to each other. Corresponding angle pairs. Okay, what can we do with that? Well, you're going to solve some algebra problems today in your homework, and this is like kind of an example of that. So it says, find the measures of the labeled angles. Okay, so when we look at the figure, we notice that we have this angle and this angle right here. We also notice that these are parallel. So we have corresponding angles because they're both on like again, think of this as an intersection. Like this is a street going through, this is a street. This is on the southwest corner of the street, this is on the southwest corner of the street. In other words, they're both on the lower left-hand side of the intersection as you're driving through here. So they're corresponding angles. Now the fact that these lines are parallel means that these corresponding angles have to be congruent to each other. So what we can do is we can use that piece of information, we can use the corresponding angles theorem to say these angles have to be congruent, which means we can set them equal to each other. I'm going to flip around here. So we can say that 12x plus 12 has to equal 14x minus 6. We did something very, very similar with vertical angles, right? When we had two vertical angles, we're like, oh, they're congruent. Set them equal to each other. Solve for x, plug it back in. So that is the same idea. We're just using a different theorem to get there. So let's group the x's. So minus 12x minus 12x. So 12 equals 2x minus 6. Let's add 6 to both sides. So plus 6 plus 6. So 18 equals 2x, which means divide by 2 on both sides, and you get 9 equals x. Okay, well that's cool, but we didn't really want x. We wanted to find the measure of the angle. Okay, so let's plug that back in here. 9 times 12, or 12 times 9, plus 12. We also have 14 times 9 minus 6. Now we know they're congruent, so that should give us the same answer. Let's check it out. So 12 times 9 equals plus 12. Okay, oops. So 12 times 9 is 108. I add 12 to that, and it looks like it's going to be 120. So this one looks like it's 120. This guy. Sorry, it kind of looks like it's labeling that guy. Okay, now this one should be 120 as well, because they have to be congruent. That's the whole point. So 126 minus 6, which is indeed 120 as well. So this one's also 120. Okay, so they're congruent. So the measures of both of these angles are 120 degrees. Okay, so that's a little blurb on corresponding angles. Now there's 3 more angle relationships coming your way. We're going to talk about alternate interior angles, alternate exterior angles, and consecutive interior angles. So pretty basic, pretty quick, but there's 3 more of these, and then you'll have the new relationships for these types of shapes.